Once we've completed our steady state tuning, the next step is to tune our engine under wide open throttle ramp runs. Now the process here is really no different with a turbocharged engine to what we'd looked at with our naturally aspirated engine. We know that to start with, our fuel and ignition timing should be relatively correct, relatively close in the areas that we've tuned in steady state, and we're going to move slowly out into those untuned areas. Let's just perform a ramp run now with our turbocharged Toyota 86 and we'll have a look at the results. Alright, we've got our run complete there and we've registered 180 kilowatts or 242 horsepower at the rear wheels. And you can see that we have our power being displayed in green at the bottom, and we've also got our red line showing us our air-fuel ratio. Let's have a look at the logging inside the M1 ECU and we'll see how we can use that logging to help us with our tuning. Now, of course, in this case, our main parameters that we're interested in for our fuel tuning are our fuel mixture aim versus our measured air-fuel ratio. And again, just like a naturally aspirated engine, any areas where we've got a discrepancy between our target and our measured, in this case you can see that at high RPM, we're a little bit lean, sitting at 0.84 lambda with a target of 0.82. We can use our correction factor to make corrections to the correct zone in our volumetric efficiency table. One aspect to consider here though is it's important to understand exactly where the engine is operating. We need to have a look at exactly what boost pressure the engine was operating at a particular point in the table, and in this case you can see that at that particular point 6,746 RPM, we're sitting at 133.2 kPa. So we actually have a ghost cursor here that shows us from our log or from our time graph exactly whereabouts in the fuel or volumetric efficiency table the engine was operating. So it's important to understand that unlike a naturally aspirated engine, the actual manifold pressure can fluctuate as we go through our wide open throttle ramp run. And you can see here at 6,500 RPM, we're sitting at about 135 kPa. We can see 135.5 kPa. So we're actually interpolating very slightly between the 140 kPa cell and very slightly down into the 120 kPa cell. Let's bring up our time graph again, and this time I want to just make note of our manifold pressure. You can see, remember I said the first step of our process is to ensure that the boost control is stable, that the mechanical boost control system is able to achieve stable and consistent boost pressure. And you can see that our maximum boost in this case is about 144 kPa. We also see that at higher RPM our boost pressure drops off very slightly back down to about 131 kPa. So in this case our boost control system is doing a good job. Now, once we've got our fueling dialed in and our ignition timing dialed in at wide open throttle during a ramp run at our minimum boost pressure, we've got a couple of extra steps over and above what we did with our naturally aspirated engine. Now in this case we've now got our tune, both our fuel and ignition, dialed in at our wastegate spring pressure level. Normally we're going to probably want to also increase the boost further to achieve more power. Before we increase the boost, what we want to do is have a look at the results we've achieved, and then we can extrapolate the values for both our fuel and ignition upwards into the higher boost areas of our table. Let's have a look at how we could achieve this, and we'll look at both our fuel and ignition. Let's have a look at the midpoint in our table here, and let's go to 5,500 RPM, which we're right at now. And you can see that during our run we were sitting at 140 kPa at this particular point. What I'll do is I'll just draw a line through the area that the engine was operating at, and what we found is that our higher RPM, our boost pressure does tend to drop away a little bit. So what we want to do is look at the values we've achieved through the area the engine was actually running, and then we want to extrapolate those upwards into the untuned areas, so the higher boost levels. And what we're trying to do here is guess ahead a little bit at the sort of volumetric efficiency or fuel values that the engine will need to see when we increase the boost and run in those areas. So let's have a look here. We've got a value of 94.3% VE at 140 kPa, and we know in this instance, if we look at our measured air-fuel ratio versus our target, this has given us the correct air-fuel ratio. Now, there's a good chance that as we increase the boost pressure, we would expect to see the engine's volumetric efficiency increase. So what I'm going to do is I'm going to extrapolate the shape of the graph that I've got, the shape of the fuel curve that I've got already that I know is correct. So I know that at 100 kPa my fueling is correct, 120 kPa my fueling is correct, and then at 140 kPa we know our fueling is correct. So if we look at this, we've gone up around about 3% in volumetric efficiency for each 20 kPa increment. We've gone from 88% to 91.6% to 94.3%. So I could continue this trend and add another 3% in our 160 kPa zone. So in this case, if we add 3%, we're looking at a value of 97.3. And we don't actually have to be that accurate. I could have just simply guessed at 98%, and we can follow this trend upwards as well, 101 and perhaps 104%. When we're doing this, it's always better to err on the side of more fuel rather than less. It's always safest to start with a rich air-fuel ratio and remove fuel rather than find that when we increase our boost pressure that our fueling is actually slightly lean. So all I'm doing here is simply taking a guess at the values we're likely to see as we increase the boost pressure so that we can be closer to our air-fuel ratio target when we increase the boost and start moving into these untuned zones. Now, of course, as we increase the boost pressure and we get to actually tune these areas correctly, if we find out that our guess was perhaps too far, we'd gone too far and our fueling is too rich or in fact too lean, then we can continue to modify the areas above where we're tuning, modify the areas in the direction of increased boost to try and fine tune our guesses and get our tuning a little bit closer. So that's what we're going to do with our fueling. Let's jump across and have a look at our ignition table, and we'll look at exactly the same process. So again, let's go through to the area we're operating in. In this case, we were sitting 5500 RPM and 140 kPa. So again, what we're looking at is the general trend for our ignition timing. You can see we've gone from 23 degrees at 100 kPa to 20 degrees at 120, and finally we know that our ignition timing is correct at 19 degrees at 140 kPa. So what I might do here is guess ahead and remove a couple of degrees of ignition timing per 20 kPa, which is what you can see I've done here. As we start increasing the boost pressure further, then it's much more likely that the engine will start to begin suffering from detonation, however. So you can see that as I've gone past my final boost target, remember this engine is set up to run 170 kPa, I've started to more aggressively remove timing. So in this case, between 170 and 180 kPa, which is only 10 kPa difference, you can see I've removed 4 degrees timing. You can also see that at 200 kPa, which is well beyond the boost pressure I want the engine to run, I've very aggressively removed the timing. You can see we've got 4 degrees in there, and what this is there for is a safety backstop in case my boost control system fails and I end up running more boost than I want. This will remove the timing dramatically and help prevent detonation from occurring. Okay, so once we've got our fueling and our ignition timing extrapolated out into those untuned areas, the next step of our full throttle tuning is to start increasing our boost pressure and start accurately tuning those fuel and ignition tables that we've now guessed the values for. So what I suggest doing here is making small incremental changes to our boost pressure. We don't want to make a large jump. We don't want to make a jump of let's say 70 kPa or 10 psi in one increment. It's much better to chip away at our boost pressure and correct any errors we're seeing in our fuel and ignition timing as we increase the boost. So generally I would suggest increasing the boost pressure in 20 kPa increments at a time. Anything more than that and we're starting to move a long way into those untuned areas. So if we're only increasing in 20 kPa increments, we've got a much better chance that the guesses we've made to our fuel and ignition timing are going to be correct. If we make a really large jump in our boost pressure in one go, there's a really good chance that we're moving so far into the untuned areas that we're likely to find that our fueling and ignition timing are a long way from being correct. So the process is to tune our fuel and ignition timing at wide open throttle at our minimum boost pressure, and we're going to extrapolate those results out into the untuned areas, and then we're going to start increasing our boost in small increments and fine-tuning our fuel and ignition timing as we go. And remember, as we do this, as we increase the boost, we can also fine-tune those guesses that we've made in those untuned areas of our fuel and ignition tables.